Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Morning all. My name is Amar Abid-Ali. I'm the Chief Commercial Officer here at the CSA Catapult. We have a great day for you today in the Green Innovation in Wales Tech Week. The first session is going to be about the international vision for DER. And it's my great pleasure to introduce Professor Will Drury, which is the Challenge Director of Driving the Electric Revolution. Will, over to you.
Amar, thank you very much. So today I'm going to talk a lot about how Driving the Electric Revolution is going to support growing international collaboration, not just about what we're doing here, but why it's important to go onto the international stage with this as well. So I've got a short presentation. We're going to go through that. And then we're fantastic that we're joined by a group of panelists at the end where we can start to talk about some of the wider issues. And also, please, if you can, any questions you've got, please stick them into the comments. We will do our very, very best to address these as we go through. So, I'm Challenge Director for Driving the Electric Revolution. This is a UKRI funded activity looking at growing supply chains in power electronics, machines and drives. Previously, I worked at Ricardo, so I've worked in industry where I was global technical expert in power electronics and head of the electronics and machines products. So, got some experience from the industrial side, as well as what we're looking to do and deliver within our challenge. So today, I wanted to give a brief overview of the challenge as a whole, what we're doing, why we're doing it, how you can engage with it, but also the importance. It's not just about the one-off collaborative R&D funding, but how growing and building this ecosystem is really important to growing the opportunities we have here within the UK. And finally, whilst we are looking at growing the UK sector in this space, there's a much bigger thing here. We are one country in the world. The importance of PEMD will hopefully become clear, but also why the export market is so important to us here in the UK. So before I do, worth just saying, who is UK Research and Innovation and what is it we do? We are the funding body for R&D through the research activities with universities into the activities everyone knows and loves from Innovate UK. So we've brought together the 8 research councils with, or not 7 research councils with Research England and Innovate UK to create UK research and innovation. And the activities that we're talking about here are cross-cutting across that whole platform that we deliver. So what is this driving the electric revolution? And I think it's important to understand that the electric revolution is upon us. If we look at any of the net zero needs of the world are underpinned by electrical energy, generating clean energy, and how we then use that efficiently. And that's what this is all about. How do we generate the electricity we need? How do we use it? How do we condition it? And they're the areas that we are interested in. So I'll explain a little bit more about that. So power electronics, machines and drives, I will explain in just a slide's time, worry not. But this is, if you take one thing away from this, this is the underpinning technology to net zero. How you generate electricity, how you use it, how we put it into batteries and take it out of batteries, all requires this technology. As a challenge, we received £80 million funding through the Department of Business, Energy and Industrial Strategy, BEIS, to deliver on this project. That is research and development projects. We've also invested in some industrialisation centres and some equipment. And Amar will talk to us about that shortly. Networking and collaboration is absolutely fundamental to this. Building a community, this is not nascent to the UK. We have world-leading capability, but it's bringing that together, creating a community that allows the delivery of this. But an outward-looking community, where the right places to work are. Where should we be collaborating with people abroad who have technologies and expertise that we need? We're looking at industrialisation. We're looking at manufacture. We are looking at, nicely sometimes, how you make things rather than what you make in itself. But importantly, we sort of talk about growing networks, growing collaboration. All this is underpinned by people. It's all about people, relationships, but also the skills, the talent, the importance of getting high quality engineering and teams around that. It's not just the engineer who sits and designs. It's also how do we grow that into a profitable business. So there's the business people, the finance people that must understand what and why this technology is so important. I promised to explain power electronics, machines and drives, so we sort of broke this down, and you can cut this cloth multiple ways. The way we've looked at this, power electronics and devices, the semiconductors, how they're packaged, essentially a switch that allows us to control the electricity, the flow of the electrons, and what that electricity is, whether in voltage, current, etc., and how we package the thin devices you can see in the image on the left. There'll be a lot more information, if that's your area of interest, in the session later on this afternoon, where we've got Swansea University as well as the CS Connected group coming to talk about power electronics. The activity has been undertaken in South Wales to allow the delivery of that and some world-class research activities. Electric machines, hugely important. Whether this is a multi-megawatt offshore wind turbine used to generate this electricity in the first place, through to fractional horsepower motors used in robotics, traction machines for electric vehicles, as well as, and there's been a lot in the press recently, about electric flight and how these can be used, so they're lighter weight. All of them have different needs, different emphasis on the specification, but all have a similar drive to be ultimately cheaper, lighter, and more efficient. And finally, drives. And in here, we're looking at, it doesn't have to be an industrial drive, as the one shown in the image is an industrial drive used for process control. But this could be any form of power converter. It could be the power converter used to charge your mobile phone up. It could be the power converter that is within a LED lights. All these have power electronics, machines and drives within them. And we also sit across the whole activity of material processing, the component manufacture. How does that integrate? And ultimately reuse and recycle. And just to add to that, we're looking across all sectors. We are called driving the electric revolution. This doesn't mean we are just doing automotive activities. We're doing personal mobility, which are very small compared all the way through to multi-megawatt, as I've talked about, wind and energy systems, as well as everything in between. So if this is an area you're engaged with, we're really interested across that whole patch. And where are they used? These PEMD, this technology, is not something that you never interact with, that is just something for the industrial people. It's already everywhere. I've touched on things like charging your mobile phone, but also washing machines, fridges, drills, as well as all the processing things. We've all enjoyed working at home. In general, I think that more interaction, social is always good, but a biscuit with a cup of tea, well, the biscuit is made on production lines. They're conveyor belts driven by electric machines, controlled by drives, steelworks, paper mills, as well as stage shows that we're hoping will reopen here in the UK again soon. So all of those use power electronics, machines and drives. They are not something that people don't engage with. I do admit you do not go to the supermarket and go, oh, I've got some power electronics, machines and drives on my shopping list, but they are everywhere you use them. I'd also say that for us, we are highly aligned to delivering the green industrial revolution that is becoming more and more important in what we do. We are able to support jobs in the green sector. This is underpinning the net zero ambitions. We are looking at growing offshore wind. We are looking at electric vehicles. We are looking at building more talent, more jobs, and we are absolutely aligned to enabling the delivery of this plan. And I've talked about cross-sector, and I talked on an earlier slide around the breadth of sectors we're looking at. And I would say this is a real advantage, both domestically and in the export space, that there are overlaps, there are additional opportunities. And those additional opportunities that link between rail and energy, or automotive and aerospace, should be looked at that. They are opportunities to maximize the growth, opportunities to maximize the market both here and abroad. And those opportunities must be taken through system views of what's happening, through a lens of it's not only about the small little bubble in which I operate. And things that then allow this cross-sector, allow the growth, allow further market exploitation, allow a higher volume of these underpinning products, which ultimately means more revenue. If companies make more revenue on this, they can invest in this cool technology even more. And that means that we can keep growing this ecosystem. So looking outside the box, looking for the other opportunities in addition to core markets is going to be really important. I said we look at the whole process, and I'll just pick on the recycling piece here. And that's really important, the circular economy. How do we take product at the end of life and recycle or reuse as much as we can? Obviously, in the forward path, we're looking to reduce the amount of these product materials that are used. But what we do need to use, how do we recycle it at the end of life? How do we prevent the end of life having just as much impact as the original thing we're trying to replace with this clean green technology? And there is work going on, and I think that, I know that Amar is going to touch on some of those activities in his presentation as to what the industrialisation centres are looking at. The bit that people keep coming back to me on, so what have you done with your money? Well, we've already run a number of competitions. So we've got £5 million of investment in high impact, high resilience supply chain projects. We've got £7 million being delivered now in fast start programs. And they are all about growing and having immediate impact on this sector and manufacturing. We have invested £33 million in industrialisation sectors, and I'll touch on those shortly. And currently, and open until 11 AM on the 30th of June. So if you're watching this on catch-up, please note that date. We have the £22 million flagship programme. So if you still have a few days to get that in, if you're already applying, welcome those. But all of this and the activities we've done are available in our annual report that is available to download, and very happy to provide people with a link to that. But we have invested in 40 projects. We've distributed that money around the country. We're scaling up activity that is already going on. I said at the outset, this is not nascent. But you look at where the money is. 23% in the North East, 24% in the West Midlands. 18% of our funding is here in Wales and 14% up in Scotland. So we are funding areas and activities that are already doing this work. This is not nascent, I will say it again. So looking at this, we are delivering funding across the whole of the UK, and that is really important. That brings me very much to the ecosystems. We want to build, we want to grow ecosystems, and this is really important. People work with people. You need to know what people are doing. We need to know how to engage with them. And actually growing and working alongside others means that this can start to build a place that people want to work. And what underpins that are people, skills, talent. How do we get more people with the skills we need? How do we look to re-skill people? There's a lot of work, certainly in the automotive space, as we approach 2030, 35 timeframe for when we're stopping selling the internal combustion engine vehicle. How do we get more people transferred in skills so that we can use high quality engineers in this new, I believe, very exciting sector? We're looking at where those gaps are. We're working with industry. We're looking to how to get more people at a much younger age interested and excited by power electronics, machines and drives. It's a bit abstract. So how can we work more at the low end? And that's really important, taking the opportunities to engage with the STEM activities. Looking at retraining, CPD, low-hanging fruit there. How can we get more people understanding this? Even at a system level, we're not after more and more people. Everyone wants to be able to design a gate drive. Well, we need people that can do that for our devices and can do the detailed at the system level, understanding the impacts of this across the whole system. And we will put in place a delivery mechanism to allow people to join up on this. And these are activities that are ongoing within the challenge, and we hope to have more news in the next short while. But with this, we have to look outside our usual boundaries of vision. We have to embrace a diverse group of people who are going to do this. We want people who come to this with different views, not the mindset that this is how we do it because that's how we've always done it. We need to access people we've never accessed before, and we need to embrace change and different ideas. And we're doing that and really striving for that within our challenge, but also within Innovate UK as a whole. This is very, very important. There are women in innovation competitions. Ideas mean business, which is looking at the age demographic. But we have to look to get people we don't even know we're not engaged in this sector. And that is hard. This is a hard topic, but it does not mean we shouldn't do it. I cannot stress enough, this is the route to a successful future in this space and growing, exciting new talent. And everything we can do to increase our diversity, increase our inclusion within it is absolutely paramount. But we are growing. We are working to grow. We're getting more and more business relationships, and we've got people from business joining us in the panel shortly. but we're building those relationships so that businesses can work with each other, playing to their strengths, creating value through that relationship, delivering on thought leadership. There is world-class research. Now we need to take the research and build it into businesses and build it into profit to allow companies to continue to invest in that. And through that, as we leave the pandemic, as things start to return to normal, we will be starting to run more and more events and networking activities in this space. I'm not going to hang around on these slides. We have an expert in Amar, no pressure, to join us and give us a talk on the industrialisation centres. But from my perspective as the Challenge Director, I'm looking for them to support SME growth, support the ecosystem development, look at growing and identifying what industry needs to be going and doing. We need to look at how we fill gaps in the scale-up acceleration in the already exciting and excellent Catapult network. And these activities are around industrialising power electronics, machines and drives. And Amar will give us much more detail. But there are 7 centres with 9 pieces of equipment around the country, and the industrialisation centre team would love to speak to anyone who wants to engage in these pieces of kit. And I would say these are the pieces we have actively invested in this time. There's a leverage of over £300 million of equipment not shown on this picture around the UK. And again, through the industrialisation centres, there is a route to accessing this in a simple, single front door approach. I would also touch on this working and us working hand in glove with the Catapult. And the whole Catapult network, you can see here, is across the UK. This is bridging a gap between the great ideas industry have, or academia have, I apologise, and how industry can deploy them. And it's starting to grow that. There are massive activities. It ranges from things in compound semiconductors down here in Newport, South Wales, through to cell and gene therapy activities going on in Stevenage, offshore renewable energy in Glasgow and Blyth, and the high value manufacturing Catapult bringing together 7 hubs across the UK, from the activities down in Bristol all the way through to those in Scotland. Talk about building this ecosystem, and one thing we've worked very closely with KTM. We're running weekly webinars. In 1 year, this is just the first year, 30 webinars, run by industry. What are we doing? Where do we see things going? And where can we engage with people? Answer close to 500 questions and in excess of 100 business introductions. Building the ecosystem is building people's business pipeline. Building the pipeline at this time, as we leave the pandemic, global business opportunity is really, really important. And now just sort of finish off before I hand over to Amar on the international market. Net zero is not our problem. And by that I mean not only our problem, we don't have to fix it within our country, and that's it. Great, we can get to net zero. The climate is sorted. We live in a single environment. We live in a global environment. We need to look for global solutions. And with PEMD underpinning this ability, there is an opportunity now to work collaboratively across borders. There are open calls in Horizon Europe that are eligible for UK companies to work with our European partners. There are activities ongoing in international collaborations through UKRI. But for PEMD, the export market is critical. I think this will come out, I hope, in the panel session later. And the international collaboration allows us to use the best from everywhere and to increase the speed of adoption and therefore delivery on our net zero goals. And I'm going to use an example here, and we're lucky to be joined by Dave in our panel session later, who pulled together a fantastic document on the magnet supply chain and the UK need for this. I've shortened the links, they got rather long. So if you do follow these short links, you will get to that in the bottom link on this slide. But they are critical global resource. And this has been in the press massively over the last few months. Huge value add as well, 60%. And there is a view by Magnetics and Materials. So we're looking at more than 2.5 times the 2015 production required by 2050. Should have included the 2050 number in there, so that's by 2050. But it is a global market. It is critical to net zero, and collaboration is the route forward. And I think this is an area we can certainly explore in the panel conversation later on. But this is a great example of something that needs global and international collaboration. But as the sun sets on what has been a very different 18 months, we've now got to move forward. Resilient supply chains, relationships with suppliers, and we have a responsibility to make a difference to the world. We have the opportunity to support corporate in delivering on their CSR requirements, their corporate social responsibilities. And we have a responsibility to develop ethical, fair supply chains. Looking only within our borders is not going to enable the global net zero challenge we are facing. And I would strongly urge people to engage in that foreign activity, looking at international activities, and we are very happy to support anyone doing that. Where do we go? We build on what I've already said are world-class research organisations and universities. We manufacture what we can, building resilient, reliable supply chains with our partners. We grow the talent pool, more people, increased diversity, higher skills, and ultimately we collaborate to give a global solution to net zero. We continue to develop on this space. We continue to say this is really important and one of the underpinning needs for net zero, and continue to engage with each other, with research organisations, and building the network we are already starting with. So please come and join us on the road to net zero. This is my one automotive style slide across all sectors, and let's make it a better world for us all. Thank you very much. And with that, I believe Amar is going to give us a bit more detail on the industrialisation sectors. Thank you.
Thank you, Will. Great presentation. Let me see if I can share my slides here, so bear with me 1 second. And hopefully I can do that. That should work. Hopefully you can see my screen now. Great. So just wanted to reintroduce myself for those who haven't been at the very start. So my role is the interim lead for DR Industrialisation Centre for Southwestern Wales. And I'm going to talk about what that means overall, but also what the DRICs have in terms of role to play in the entire DR story. You've heard from Will about the importance of driving the electrical revolution with power electronics, machines, and drives overall. And so this is all about the translation of this into industry, right? And making sure that these things take into reality. So I'll walk you through briefly the background to this. It's going to be very short in terms of why we're focusing on this from the DRIC perspective. And then I'll walk you through the main areas of focus for us and talk about the equipment. So we all know the challenges that are there. 2035, all cars need to be zero carbon by then. We know that the aircrafts need to move to electric and hybrid to meet the next phase of the emission legislation. That's by 2040. So we also know the renewable, the wind, wave, and tidal, all of those requires a huge amount of reduction, 80% CO2 reduction by 2050 as well. So you can see that the number of challenges that are out there are pretty substantial. In order to get this to be tackled, there is a requirement really for industry to play a massive role in this. This is where the DRICs will come in. So if you look at what it is that the benefit it should bring to the UK PLC, obviously starting off with the best possible equipment that we can get on it, so state-of-the-art equipment. How can we get the transition from the ICE engines all the way to electrification? Of course, we're looking at the industrial growth, and you've heard that from Will very strongly in his presentation, and obviously to help with the government net zero agenda, right? And get all of the 2050 climate commitments. This is going to require an enormous amount of skill for PEMD. So engineering talent is going to be part of what the RICs are going to try and promote and grow as well. And of course, making sure that the academic leadership that's in the UK is translated into industrial leverage. So this is the reasons why we exist. Now, looking at the network itself, it's actually 4 centres overall. So you've got the materials and components in southwestern Wales, and I'll talk about that in a minute. You've got the machines and drives, prototypes and scale-ups in Midlands and in Northeast. And then you've got the machines and drives and high-power PMD in Scotland. And that is in Strathclyde University. In the Northeast is the University of Newcastle, and machines and drives for the Midlands is pretty much in WMG, University of Warwick. So as Will said, this is not just about equipment. It's obviously the expertise to use it, but just to put things in perspective, there is already about 300 million plus worth of open access equipment. And it's important to recognize that there is a lot more than that generally, but they're not open access. So the open access equipment there is pretty substantial, but equipment without expertise is meaningless. And this is, again, part of what the DRICs are looking to resolve. If you look at where the majority of the academic partners are, so this is some of the academic partner network that are helping us out in the DRICs. And you can see it's all different universities all the way across the whole of the UK. Now, looking at our existence and why we exist. So to summarize this, really, the 28.5 million funding that is for the equipment is only a small part of what the RIC is all about. The 10-year vision is essentially to be recognized not only in the UK, but actually globally as a center of excellence for PMD. And we all recognize how important that is now with electrification overall. So the mission is really to provide that network of open access facilities I talked about, and Will talked about previously, and to work with all these industrial partners to develop this UK supply chain, absolutely of paramount importance. And of course, that means becoming a lot more attractive as PEMD solutions providers for global markets. So in order to do that, we had to do a bit of homework. And that homework was to look at what supply chains was required for power electronics, and the same thing on the electrical machine side of things. And through that, there was a tender process regarding where we needed to invest on equipment. And so when we talk about power electronics, is everything from the semiconductor production to bonding, lead frame, all the way to the packaging, PCB component, and all the way up to the system integration. Looking at it from an electrical machines perspective, it was pretty much from the magnet material all the way, again, to the system integration throughout all of this. And where we identified there were gaps and where there was a requirement for state-of-the-art equipment, that is what was added. So what Will showed in his slide about the 7 equipment recipients, this is the equivalent of it here. As you can see, those are the 7 locations. What I'll be talking about in my presentation is what we do in the Southwest and Wales Center, which is based in the CSA Catapult. And so therefore that will include what we have in the Compound Semiconductor Catapult, what we have in Swansea University, but also as we are dealing with materials and components in that center, that's where the focus area for us is. I'll be also talking about University of Birmingham and what are they doing there in terms of magnetics, recycling, and magnetics materials. So with that, I'm just going to go ahead and look at what equipment that we've recently invested in at the CSA Catapult, or investing in the CSA Catapult. So to put things in perspective, it takes a while to actually go through the tender process, figure out what the right equipment are, and then get it commissioned and live. All of the DERICs at the moment and all of the equipment recipients for this are working through the setup of it and the commissioning and the tender process. So we estimate that the vast majority of this will be ready by end of this year, beginning of next year in terms of being set up. But I want to emphasize that this is not the only equipment that's there. There is already a lot of capability in place. So we're ready to engage in multiple areas. These are equipment to add to the supply chain, to strengthen the supply chain, to strengthen the equipment availability that we have and the expertise. So at the CSA Catapult, we are focusing on the additive manufacturing. And the reason for that is, if you look at PEMD applications, they generally require smaller, higher speed, and higher efficiency power electronic systems. So compound semiconductors and wide band gap devices, they can offer many advantages over their silicon equivalents. But of course, that also means that with the smaller die size, it's increased current density, and that has increased operating temperature, which means that the thermal management becomes an issue. And of course, in order to deal with that, ceramic materials we know have better thermal management properties. So one of the reasons why we're investing in the ceramic printers is to really tackle that element there. So the ceramic printer that we'll be investing in is in the printing ceramic materials like alumina and aluminum nitride. And this is, again, part of this 28.5 million investment that comes from UKRI and what all these equipment that are there. So you can see how this then fits the gap on the thermal management element. If you look at the metal printer that you see there in front of you, that is to resolve a lot of the issues about the switching frequencies, the shorter interconnects that are there, and moving from wired to wireless bonding, which means increased parasitics, and you need to make sure that you have everything within the same device. Essentially, what I'm saying is that a lot of these equipment are chosen because they solve some serious issues in power electronics and machines and drives. And they are different for various centers, of course, and you can see here the supporting equipment from specialist ovens to metrology tools and the rest of it. So looking at then where this equipment can help. So of course, all sectors are pretty much supported with this. And the type of projects that you can engage with us on is anything that requires robust thermal management, faster switching, higher density integration. Essentially, almost any power electronics requirement as it stands. Because all PMD requires essentially a range of smaller, higher speed and higher efficiency systems overall in order to achieve its highest potential. So moving on to the equipment that will be in Swansea University and also in Newport Wafer Fab. So the equipment here is for Synapse, SiC, deep etch tools, and high voltage test stations, and the back contact laser anneals for them. Essentially, this is an entire pilot line, a wide bandgap semiconductor power electronics pilot line that does everything from the deposition to etching to contacting, grind, and dice. Everything you require to really actually have the whole ecosystem for it. Again, availability-wise, beginning of next year, and will be rolled out throughout the year next year for full pilot line availability. And for sector supporters, everything, again, in terms of the top sectors there, the projects, anything to do with process material and architecture development or troubleshooting, advanced test and measurement, and component integration. If you think about those main elements, that's really where this new equipment will help with. So moving on to the equipment that are with Birmingham University. So the interesting thing here is that we're looking at a recycling process line for rare earth magnets. Now, I just want to step back a little bit in terms of putting this in perspective as to why this is important. The majority of the electric motors that are out there today use neodymium magnets. In fact, there's about 85% of all electric passenger cars use this material. So they are generally the strongest type of permanent magnets available commercially. And they have over the years replaced other types of magnets in many, many applications in modern products that requires strong permanent magnets. Now, this obviously becomes critical to PEMD, and therefore it has also recently increased in price dramatically, right? So that price increase has made it even more important to look at the recycling element of these magnets. And so when you look at this, this investment will help the development of a complete supply chain that is capable to produce about 20 tons of recycled magnets a year that would otherwise go to landfill. And so quite a critical part of the ecosystem. So that will also resolve the capacity issues that we're seeing there, and therefore hopefully alleviate some of these price concerns and those increase in prices, but bearing in mind as well having that green energy element to it. So this is managed by the Magnetics Materials Group, MMG, at the University of Birmingham, which is, by the way, the only UK research group focusing on processing and recycling permanent rare magnetic materials. And this is supporting the UK supply chain for these rare earth magnets, as well as the recycling and the magnet manufacture, as well as the characterizations of the magnet materials and the new manufacturing processes. So quite an important role played here by University of Birmingham for this. And again, University of Birmingham equipment, as well as the Swansea equipment that you've seen, also based in Newport Wafer Fab, and the CSA Catapult equipment, they're all part of the Southwest and Wales DER Centre leverage for the industrialization of DER. So I just want to reiterate what Will showed in his slides there, in that the technology scope is really all the way from raw materials or raw minerals all the way to the system integration. And you saw some of these examples there in what I've showed with the University of Birmingham, and also what we're doing in terms of the device setup and the packaging and the additive manufacturing overall. So we are pretty much already there for business. We are there to help you with any PEMD project. And the way to get in touch with us, oops, sorry, let me go back one slide. These are all the contacts you need. We're available everywhere in all the social media channels, but also these are our contact details for not just Southwest and Wales Centre. Remember, as Will said, we're one front door. So if you need anything throughout the entire DER industrialization centres, any one of us can actually point you in the right direction when it comes to it. And with that, I think we are getting to the panel side of things. So let me just stop sharing. Hopefully that stops sharing now. Excellent. Brilliant. Good stuff. So I'd like to formally welcome the panel. I think we're okay on time as well. Perfect. Great stuff. So on the panel today, we have, and you've heard from our keynote speaker, Professor Will Drury, Challenge Director driving the electric revolution. We have Martin McHugh, CEO of the CSA Catapult, Compound Semiconductor Application Catapult. We have Dr. Tanya Trajkovic, CEO of Cambridge Microelectronics Limited, Chemitronics. We have Dave OudeNijeweme, who is the head of technology trends at APC. And we have Dr. Simon Hart, Chief Technology Innovation Officer at YASA. I think I've mentioned everyone. Welcome everyone to today's panel. I appreciate your time. We have a set of questions. How do you want to play this well?
Right, so I think we've got some ideas here. For those that see me and Amar, we are socially distanced in the same room. We have some sort of starter questions, but really, I think this is also an opportunity for you guys to come in from the audience. If there's topics that you say, oh, that's interesting, or what's your view on, based on what you've heard already and what we start to discuss here, please do pop them in there. And if they're really hard, then I'll distribute them evenly between the panelists. But I really want this to be a very open round table starting. We'll start with sort of questions to people, but we're going to sort of chip in, try and give you a view that we're seeing from different perspectives. But I think a sensible place really to start, probably with you, Dave, is sort of the main trends in PEMD. Obviously, APC is focused on power electronics, but I know from a wide number of conversations we've had, you've got a few much bigger than that. But what do you see as the main trends in PEMD and their impact to deliver on net zero?
Well, I think on a very sharp answer, we see lots and lots of them. I mean, you were talking about uptake, global uptake. It's very, very significant. It's huge. Effectively, you can say this is a second industrial revolution. However, it doesn't happen in a whole generation. It happens in about 10 years. Between now and 2030, pretty much all the cars that we all know and love will have to go to zero emissions, which means there will be an electric motor that people might not know about, but there might be two even, over and above your starter motor and windscreen wiper. So they're quite large. All the underpinnings need to be in there. And then there is something like a battery as well, which I know catches all the limelight, but you can't drive on a battery. It's great for energy storage. Nobody talks about a fuel tank in their car. It's the electric motor that drives it, and the power electronics behind it that you and I won't talk about. But without those, you don't go anywhere. So it's enormous. I mean, we did a little bit of estimations a couple of years ago, and just for the UK, we thought there was a market just in automotive of about £24 billion that the UK could address in certain areas by 2025. My guess is that is now looks very, very conservative indeed. I think we could easily double that and still look at this. So it's an enormous market, and it's, as you say, right here, right now, and it's a global market, and the UK can and should really play a part in it.
Thanks, then. Simon, sort of you're working for a tier one in YASA. How do you sort of see that high level? It's massive. How's that filtering down into sort of component level with you guys? Are you broadly in agreement? How do you see movement there?
Yes, definitely. I mean, we see it accelerating. And it kind of provides a platform not only for certain companies that happen to be riding that wave, but also UK and a lot more than just riding yet another wave. It gives an opportunity for step change in a number of ways we operate. We might talk a little bit later about international exports, etc. But getting a good foundation and not just leveling the playing field, but also raising our perceived game. We know we're good at with technology, but it's also making sure that internationally we can back that up and really show we are really ahead of a number of other other areas. Yeah.
And Tanya sort of talked about raising our game and looking at new technologies and things. Obviously, the work you're doing with Cambridge Microelectronics and things is very relevant to that. Is that uptake what you're seeing from the device manufacturing side as well across different markets?
Right. I think device manufacturing is mainly focused abroad. I think there is not that much effort in the UK, but saying that doesn't mean that we cannot really innovate, because we can work with companies abroad and then innovate at the device level. However, from our point of view, because we are not only device experts, we are also engaged in packaging and maybe integration solutions and various solutions that are based on devices, but are looking a little bit 1 or 2 steps ahead. And I think there is a lot of innovation that is possible to happen in those areas when all these different areas of power electronics are somehow working together and trying to innovate something. And I have to say that I have been very pleasantly surprised by today's presentations and all the efforts that have been happening within the UK in terms of forming supply chains and really enabling innovation to happen in the UK. Because my view from maybe a year or 2 ago was that there is a lot of capability, but it has been somehow separated into small locations, into small groups. There was no communication between these groups. And I think that lack of communication and teamwork was really slowing us down. But seeing now that we are investing a lot into the equipment used for assembly, into having some advanced techniques for assembly, for integration, I think it's giving us great opportunity to realize some of the ideas that we already have, but we just don't have places where to realize them and where to take them first as some sort of demonstrators of the technology and innovation, and then maybe develop further into a proper manufacturing supply basically place.
No, that almost without I promise none of this is scripted. It leads me really, and Martin, the Lord's Science and Technology Committee has very recently praised the Catapults for bridging that gap between research and industry. And I think Tanya just spoke there about packaging. That's obviously a really exciting area. But do you see that then growing, and this ecosystem we talk about, including the Catapult and the academia coming together? How do you see that sort of starting to move forward?
Thank you, Will. I take Tanya's point on packaging is very pertinent, having a packaging background myself. But I think the Catapult really sees itself as the sort of and in the R&D. We are there to connect the research base and the business base through development. And I kind of often characterize that we're there really to help grow supply chains, help convene supply chains with our help in sort of CRD programs and everything. We're there really to help the skills base as well. So we're developing a skills academy in this area. We've spent some time developing our technical support in terms of the modeling, characterization, integration with the packaging and validation. And on the horizon for us is actually to develop our scale up in terms of incubation and sort of helping people access finance. So, from a Catapult side of it, we see our role very much as, and that's why we were keen on the DER Centre, is actually helping industry connect from the component level right the way through to the PEMD device. So for me, Catapult's in a very sweet spot in terms of technology. It's in a very sweet spot in terms of the convening of the supply chain, and in a neutral convener of the research base and the industrial base. So totally get where people are coming from.
And Simon, Tanya sort of touched there on the lack of UK supply chain at device level. There's a little bit more maybe around packaging that I see. But what's the sort of thing that you would want to see that make you go, yeah, I'm going to invest in the UK supply base at device level, for example, rather than buying an imported device, or actually we need to have a much bigger view of this. There are some things to play in a bit smarter.
Yeah, I think Martin, and Tanya have hit upon this really. That there are pockets we need to join them all up really, and getting very good competence in certain parts of the supply chain flow, particularly around the power semiconductors. Bearing in mind that the power semiconductors, the actual switches, are so important with power conversion. From the DC to maybe the AC that we need on the MOS and things. I think it's joining those dots and in such a way that doesn't just heighten our technical expertise in several silos, but instead shows that we can link all those together, in traceability, quality, reliability, all these kind of things that you need to have to give a complete package. And I don't mean just the semiconductor package, but also the kind of package of development information and a very much bi-directional communications with the users, the tier ones, and then ultimately the OEMs as well. Because as OEMs are finding their feet in these markets, their top level specifications are changing. Now, over the last 2 or 3 years, we've seen them kind of focus on particular power ranges and actual vehicle mileage ranges and things like that. But feeding all of that back all the way down to make sure that we get the most optimized switches, power electronics is very, very important.
And Tanya said that you work abroad to make these devices. Are there certain initiatives or activities that make the UK more attractive for companies such as yours to invest in making the device, not just designing here, but making these power devices in the UK?
I think we don't have suitable facilities to make state-of-the-art devices. We may have facilities that are capable of fabricating silicon carbide devices, silicon or GaN devices, but there are a few key steps that need to be added to those standard processes in order to make them very competitive. Because the world has been moving very, very fast, and there has been a lot of innovation in all these different areas. And I think if we want to really bring the UK to those high levels where the rest of the world, mainly in Asia, I would say China, Taiwan, obviously, Germany, where they are right now, we really need to invest in manufacturing capability. I don't mean to build the whole manufacturing line, but maybe bring in some advanced tools to the lines that already exist. Like the deep etching tool, I've seen now that Swansea University is adding that to their capacity. Then we need some thin wafer handling for the backside metallization. That's very important. And also it's very important for the GaN devices, I think, development of redistribution layers. That's one key step that is standing between having a GaN device and having a module based on GaN devices. And I think these redistribution layers are very important. And at the moment, in the UK, we don't have a clear supplier of that technology. So I think we need to invest, not much, but we need to invest with target technologies and target tools for each of these technologies so that we can enable them to be very competitive.
Cool. The Driving Electric Revolution Industrialisation Centres are looking to try and support that starting the manufacturing process onto commercial volume. And is that an area that you're seeing the growth in your activities of the sectors?
Absolutely. I think the majority of the challenges we see in there is that because there is lack of standardization across all the power electronics modules, for example, that tends to be an issue that a lot of the industrial partners are asking us about. And then you look at the optimization, which was touched by Simon and the others. Again, you look at the standardization, the optimization challenges that are there. These are critical for anything that's, for a scale-up possibility. So when we talk to customers throughout the DER industrialization centers, at the moment there is a lot of engagement, obviously, with the challenge, the DER challenge, which is the CR&D project. But we are also engaged on figuring out how we can actually help with getting at least some level of a common state to play with. Meaning, if everyone had a standard module for electrification, power electronic module, that will allow for quite a big adoption of this, and it will enable it to be much faster. Now, this is one of the challenges, but we see a wide variety of challenges, but they're not necessarily only to the device level. It actually starts off material, device, module, the sub-module system, all the way to the system level. And it's clearly getting to the point now where all these challenges start to group into major element that we're trying to resolve.
So you touch on there, Tanya's sort of mentioned GaN. Simon, do you see a sort of drive for technology solution at the device level, whether it's going to be GaN, silicon carbide, or people are actually going to stick with improvements in silicon IGBTs over the coming, or is that one?
So yeah, I mean, it's not altogether easy to say one size fits all. Once you've got a particular package, as Amar says, you optimize that and take that forward. But there are lots of different power electronic converters, within a vehicle. Some of them, suit faster switching, for example, chargers and things like that. Some of them suit slightly slower switching, such as the power control for motors. So, when you're starting to look at optimizing the whole system of a vehicle, you've got a number of different players on there. You've got, cost, range, reliability, these kind of things. So you can't just look at your power controller or your battery charger or what have you in isolation. There are still situations at certain power ratings where, silicon IGBTs have still got a very bright future. We now see a general adoption of silicon carbide as the first step into wide bandgap. Again, this is for efficiency reasons, but if you look at topologies, if you look at where you're using these power devices, you'll find there are still sweet spots, for other silicon devices. And of course, GaN fast switching, there are parts of power converters that we can employ them now, and as they come more and more online, that would be useful as well. And of course, we're looking at the next technology. But we've got to remember that the automotive and aerospace and all these industries, they're based on reliability and quality as well. We want to get those technologies out, those differential technologies, and get out in the marketplace. But we don't want recalls. We don't want failures and things. And for all our simulation, for all of our work that we can do, right at the beginning before sending new technology out into the field, there's no substitute for getting numbers of hours and number of units, and really, you push out your unknowns, if you like, and so just turning that round a little bit for UK, looking at a particular power module, and a complete supply chain. The journey to getting thousands of hours on many vehicles takes time. So it's not just about getting really good technology that's selected and optimized. We also need to get it into vehicles, and this is where Amar's point about getting a kind of common design means that same unit effectively can be used in lots of different applications. So aggregate, you get a lot more hours of use out of it. And so when OEMs approach us and say, what you're looking at technology, and we say, oh, this is great technology, they immediately say, okay, so what's your route to de-risking? So it's not just we can rapidly innovate and rapid deployment of technology. That's great. That's a differentiator. But there's also the how can you rapidly de-risk that technology as well for quality and reliability reasons, and that's where we come to having common units that we can use in many different applications to get those operational hours, and also the kind of corner cases of their envelope of operation as well. Start filling those out as well to provide the whole story for these particularly the power switches.
And Martin, I can see you nodding away with some of what Simon was saying there. So at least we've got one person nodding away, so we can't see the audience, but Martin's given us some reassurance. But there, Simon touched on two things really that are of interest. One is sort of the common package Is that really possible from your packaging experience? But also the absolute criticality of reliability. That is do or die on that. It's not reliable, it won't be obtained. And then we sort of understand from Dave as well on the wider picture of that reliability and the importance in the automotive space for those components. Nothing.
I couldn't hear you very well, Will, sorry.
The reality is packaging for multiple applications. So we can have a common packaging across different devices or different for rail, for energy. Is that really going to happen? I think it's my question.
I think it's an interesting question because my own experience has been that and Tanya and Simon have partly touched on this, is that it's to do with scale. I think once you actually have a secure design, a stable design, I think industry itself can actually stack up to that if the actual business case works. I think the difficulty is when we've got lots of little disaggregated standards and types of packaging that, what actually happens then, there's never enough scale to warrant the investment and the build-up. And we saw this, very much when I was in the implant grade module business, where it was all bespoke, and it was 20,000 of this and 40,000 of this, and it was never big enough to go to the Far East, and it was never big enough in scale to get the sort of cost down. So I think we do have a challenge, and I think for the UK, it's actually in desperate need of a good mapping exercise, which Tanya and Simon have actually mentioned, where I think there are parts of it that can actually be filled. So, we can get the modules to be less reliant on intricacies of wire bonding and more on assembly of packaged devices, then there's a good capability in the UK to do module assembly. I see the challenge is that transition from the bare die into a sensible package level. And the challenge around making that happen in a reliable way. I think semiconductor technology reliability is well understood. Wire bonding in a package is well understood from a reliability point of view. It's just when you start changing the mix, I sympathise with Simon's point about you start getting asked for reliability data, and we don't have that. And maybe we need to take some inspiration from the vaccines program that was, where we've actually been able to accelerate the gathering of reliability data and use other data and bring it together to kind of take some of that sort of risk appetite away.
I think we've spent quite a while here. Sort of, you've got a lot of power electronics people, but Dave, the sort of electric machine market is enormous also. And it is an area that we're doing a fair amount of innovation, both with Driving Electric Revolution work, but also activity data funding. Where do you start to see that technology going? And what areas should we be looking at for the future?
Okay. I think, first of all, it's probably worthwhile picking up on all these points. Really, I think what we're talking about here is the growing pains of industrialisation. It's great to do the R&D, and the UK, as we all know, is pretty decent at that. Where it's not so good at, typically, is to actually start making some money out of that and to get to manufacturing. And that's really where we're focused on, because it is very much a burning platform. I mean, Simon knows about this. You're trying to get to market. You're trying to get to market quick because there is a market out there. And the market is, as I said, at least 24 billion by 2025. That means for car companies, you need to start building that stuff now. It's designed now, and the contracts for procurement contracts are signed in the next year or two. So yes, I know we need to, deal with all these problems that everybody's talking about. And I'm not a technologist in power electronics or magnets for that matter, but this is being done at scale at the moment. And if the UK wants to have a piece of the pie when you start coming up with some answers pretty rapidly, including standardization, which was, you know, a massive tier one and a one of the biggest automotive companies in the world coming together and say, this is what's needed, and we need it now, not tomorrow, now. And I think these things are burning platforms for us, and I think we need to, you know, do something with that. So how do I see it going forward? Also from the magnets piece, why do we swap between power electronics and magnets? Well, within a motor, the biggest cost contributors are the power electronics going to silicon carbide, gallium nitride, or magnets. Is another enormous cost element to it, and not just a cost element to it, but this is a global market. You know, people are addressing these things globally, and I think the UK has a part to play within that. But as I said, we need to start playing that part quite rapidly, and that is another sort of thing between magnets and power electronics. From a market perspective, the whole supply chain needs to be brought together. To Tanya's point, doing little bits here and there, sorry, it's just not going to cut the mustard. And I'm a pragmatist as well. I mean, this can work in the UK, you know, but we need to start doing something at scale, which is what what Will and all of us are working towards quite heavily. But that's what needs to happen pretty swiftly. I think, Will, you wanted to speak a little bit about magnets. Is that correct?
Yeah. So we've touched and we've sort of talked a lot about the magnets, but things like electric machines are. If you want a smaller, lighter electric machine, you want it to go faster, so you're getting your power out through speed. That obviously links back into some of the power electronic systems that are starting to allow us to do that. But where are these moving faster? Are they? There's been talk in publications on different winding materials, different permanent magnet-free solutions, etc. Where do you see that starting to evolve towards?
Yeah, so, well, I think a good starting point is some of the Automotive Council's roadmaps that my team have just updated. But really what you see is, as you say, wide band gap materials to do the switching at higher voltages, higher currents, both. Faster switching in some of the areas, so that's probably more towards GaN, as you said. But magnets is a big issue for us. I mean, it is a technology that is very much monopolized by China through decent strategy on their part, and Japan to some degree. So is there a lot of focus on going magnet-free machines? Yes, there is. Can we see it coming very quickly? Well, it is coming, but still the forecasts are that in the order of 70 to 80% will be with permanent magnets in for the time being. I'm sure if there are supply chain issues, which there most likely will be, then car companies will start to design these out pretty swiftly. But for certain applications, such as wind turbines, that's near on impossible. So regardless of all these things moving forward, you'll still need permanent magnets. And then there is winding materials. Moving maybe away from copper to aluminium might well be possible for higher speed motors, but comes with a whole set of its own problems. Further advances in electrical steel, I think, is another area where there is a lot of further development to be done, and sense of excellence around the R&D of that, at least in the south of Wales. So we can see lots of things, but closer to home, very simply, housings. Yeah, it's a cast housing and a machine to order. Yeah, it's all very well, but there is a lot of very detailed casting techniques and machining techniques in there that some UK companies do quite well currently for engines that need to transition to what's required for e-machines. And all these things all need to come together. And it's that integration that, for example, Simon does within their company, that's where a lot of the real technology lives. And then moving that from an R&D to a how do I make it at scale, at cost, at quality, that's incredibly hard. And to transition from that space to a tier one, which is what YASA is just about to do, is really, really difficult in automotive industry, and it's happening on our shores.
And I think that sort of plays into you touched there on higher voltages, but many of these alternative applications within the automotive space. But I think, Tanya, sort of on the gallium nitride, where are you seeing the sort of key markets at the moment for this technology that is, as far as I can see, please correct me if I'm wrong, slightly behind or less mature than, when I say behind, I mean less mature and proven in the marketplace than silicon carbide? Doesn't mean it's not going to catch up in the very near future.
For much longer than silicon carbide, but not at these voltages that we are now looking at, which is 600 to 800 volts for automotive. So definitely GaN has a long life in automotive industries. But one of the things that I would like to mention, following what Simon and Dave have said, is that it's not only important to make a better device and use a more reliable device, we have to look at the whole system as one body and try and understand which part of that system is actually the bottleneck of delivering better performance. So in many cases, I have seen system designers just add one resistor here or there to improve maybe, I don't know, some reduce some oscillations and things like that, but that puts maybe a lot of stress on the device, and then there are reliability issues. So then we go back to looking at semiconductors and looking at the system, and we have reliability issues, and we are back to square one. So I think there has to be communication within these different teams that are used to build a system, so that every change that is made is actually agreed by everyone, and it's actually the best change that can be made. Because there are many ways you can solve a problem, and maybe there is one option that is much easier than others and maybe less costly. And another thing that I wanted to mention is that we are all trying to improve basically the output of a system. We are trying to drive devices at higher temperatures, and that's all possible. So we have devices operating at 175 degrees, at 200 degrees. But then when you try to integrate these devices within a module, and you try to build a very efficient module that will operate at high temperatures, then you have other showstoppers, like for instance, gate drivers, that are all limited at 150 degrees. So there are no gate drivers that operate at 175 degrees. So then, although you have materials operating at 175, you have semiconductor devices operating at higher temperatures, you still don't have one building block, that is the gate drivers. You have to put it outside of the module, which makes then parasitics larger and increases the losses. So back to square one. So I think we need to really all work together. And I think in the UK, if we could maybe make a virtual OEM where we have all these different parts that build different things and are experts in different areas of creating a very commercially acceptable and attractive power solution. I think if we use all these different teams and put them to work together, I think we can build something very special and something that is going definitely to lead the markets in the world.
A nationally vertically integrated supply chain, Tanya, is sort of what you're suggesting there.
Yes.
Simon, you look like you were going to come in on that.
I was just agreeing. I mean, yes, that's this idea of a virtual OEM is I think quite an interesting one. I mean, we are focusing on certain high cost items, but as Tanya said, I mean, we're putting very hot devices near to capacitors, DC bus capacitors, and in the power electronics, the capacitors, for example, now in certain designs are take up more volume than the actual switching devices, including their thermal management. And you're going to put them next to something hot, and they don't naturally want to be too hot themselves. So they naturally get bigger in volume. So your box gets bigger in volume, and we could get ourselves in a kind of localized optimal peak rather than the kind of global peak, unless we, as we were saying, unless we look at the whole, the broad nature of engineering and look at it as a system optimization, as has been pointed out. But to do that, you need initiatives that bring people together. And I kind of wanted to talk about ecosystems and these kind of partnerships and things, because, you know, my earlier point about, you know, riding the wave and rapidly, you know, keeping up with it, you can't do it on your own. You need partners. And when you're rapidly developing technology, again, you can't do it on your own. You need partners in Catapult and universities and other folks. You also need kind of safety nets of test capability to get the reliability as well into that. So a lot of the DER initiatives, you know, particularly for the technology, the supply chain, and the ecosystem kind of networking, align really well with where I think we need the kind of solution to the problem. I mean, I don't think we're there yet. You know, and it's going to be a road on this, and we touched on quite a few of the points today, haven't we? There's a lot of really good work, and I think it's joining up the dots, and as we were saying, you know, these maps and these virtual OEMs and these kind of linkage and bi-directional kind of communications of specifications and issues and things like that, to solve it as one kind of integrated number of entities. You know, from tests, from universities, from companies, and, you know, effectively not just in the UK, but also looking out, you know, across Europe and the rest of the world, particularly from the kind of OEM pull. So really, you know, joining up all the way to what the customer wants.
That must be music to your ears, Martin, as the Chief Executive Content and Conduct Applications.
I think it's interesting, Will. I mean, it's coming back to why we thought being a sponsor of the DER Industrialisation Centre was the right role for the Catapult. You know, and it's the big takeaway for me for a lot of this now is the mapping exercise. You know, the Catapult has done mapping, but I can see where Tanya and Simon are coming from, and David, that, you know, have we mapped it down to the next level of granularity in terms of the you know, the components. And it doesn't matter if some of it's offshore, and it doesn't matter if some of it's missing, as long as we know some of it's missing, because that would then give us the gap we got to finish. Yeah. So very, very interesting from my point of view. Yeah.
And Amar, obviously for the centres, this is bread and butter sorts of activities that you're playing in.
Absolutely. The supply chain mapping, the supply chain interconnect, the understanding of the capabilities and the expertise, and that one front door, it's going to take a while for it to actually bed in and work properly. But I think this is definitely the starting point of how we can bring all of that. Bearing in mind, this is a logical construct, right? So this is not about having a physical center anywhere. This is why it's using the existing infrastructure, the existing, you know, for example, we're based for the Southwest and Wales, we're based at the CSA Catapult Innovation Centre, which already exists. If you look at University of Newcastle, their location already pretty much exists. It's not about spending money on the location, it's more about getting the actual connection between the various companies to work. So I think there is a lot of work to be done, Will, on this, but it's exciting work. It's already started to happen. We can see a lot more engagement coming into it, which is always good. But the challenge is going to be quite big, and it's realized by the industry. And I think every time we speak to customers, this is reiterated. And this is why, more than ever, I think the importance of the industrialization centers is really to actually be as close as possible to industry and figure out exactly what those challenges are. And I'm glad to say that those interactions are really increasing exponentially at the moment, which is great.
So I'm conscious of time, and I don't want to be shouted at by people for overrunning. So I'm going to wrap up in true Zoom before go around the tiles on my screen. But the question is, and it's an easy one, I promise. Given a magic wand that we can make a significant change to something to allow us to grow what we're doing in PEMD here in the UK to be more internationally attractive, what would it be? And I will start at the top left of my screen. So that's Tanya. Apologies, you first.
That's all right. So we have nodes. We need to build a network. and we need to just get easy access to this network. I think from my point of view, we have a lot of facilities that are not really fully utilized because maybe they don't have key pieces of equipment. And I think that would be for me the primary thing we would need to really do, to buy some state-of-the-art pieces of equipment or upgrade existing equipment so that it is capable of delivering something new and something quite attractive for the users and for the customers worldwide.
Cool, thank you. Amar, you're next on my screen.
So I think I can maybe summarize it in 3 words, right? Connect the supply chain, project the supply chain outwards, and scale up the supply chain. Because ultimately, this is where the strength of the entire PEMD would be, right? We have the right universities, the right expertise, the right equipment. It's all about making sure that that actually is projected in the right way. It's connected in the right way. Its collaborative nature is done in the right way. We're punching above our weight when it comes to it in some cases, but in most cases, we actually have a lot of talent that is out there that just needs to be really explored and exploited.
Fantastic. Martin.
Sorry, Will, I was just making some notes myself, getting ready for the answer. I think if it was in my true creative style, and if it was a magic wand with lots of shiny dust coming off the end of it, Will, I think in one sense, I would almost go back and say it would be great if we had a universal design already that we could construct a supply chain around, and then from there, the improvements to that design could be made because you would have the data, then you could actually make the incremental steps. I think if we had the magic wand, I think we had that or a standard that we knew that the industry wanted and could drive volume, then I think everybody from Tanya to Simon and co could actually migrate and develop towards that, because you're actually heading for an end market, and that's where everything else comes from. So that would be my fairy godmother request.
Simon, we've got about a minute left, so you've got 30 seconds before we.
Sure. If we could put in these initiatives we've talked about today to kind of reaffirm the technology, the ecosystems, and the supply chain elements, and then be able to package that and explain it in such a way that new entries to the market and people within the market can understand it and get running, hit the ground running really quickly, and also be able to exploit that to the world and show this is what we can do in Wales, where I'm speaking to you from, and the whole of the UK. That would be great.
And Dave, you've heard a lot today.
I'm going to go very specific. Very specific. If by 2025 we could have 10 kilotons of magnet supply chain from mine all the way through magnets and the recycling, then I'm very happy, and we're working hard towards that. But that's an industry goal, yeah, and I'm keen on that.
Fantastic. So I think we've covered a huge amount of ground there, guys. I really appreciate all your time to join us this morning to sort of kick off Tech Week Wales, and we have had a hopefully engaging output from the audience. So I thank you very much. I would like to thank Amar for your talk today. It's been really good. Anyone wants to reach out to us, please do. You've had everything. We've posted a number of links there in the chat, but I wish you all the best. Stay safe, and I look forward to hopefully meeting some of you in person very soon. Thank you very much.
Thank you too.
Bye.
Bye. See you then. Bye.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.